Okay, we should be live. Yes, we are already. So today I want to try Cryptozombies. I don't know exactly what is that, but I want to try this publicly. So let's get started. Thank you, Karwak. Nice. Okay, so let's start here. By the way, if you want to stick with me, if you want to also do this tutorial, I'll send you the link. This is the link. This is not a sponsored video, it's just me trying stuff, by the way. Okay, so learn to code blockchain dApps, which stands for decentralized apps, by building simple games. We all love to create games. So there are two options here. The Libra, never heard about this. Libra is also a zodiac sign. Perfect for absolute beginners. We walk you through basic concept of the way, no coding experience needed. But I want to try this one, the Solidity one. The most popular course in learning Solidity programming language they want to call it like that. As long as you have some basic coding experience, you will be a master of Solidity with only this course. So this is the promise that they are doing. I like that there are these webs here. Open chat. Let's just take a look at this, and then we will start. So, interactive coding lessons in browser step-to-step lessons take you from the very basics of Solidity to creating your own fully functional blockchain-based game. Even by the end of lesson 1, which can be completed in one sitting, you will know enough to officially call yourself a blockchain developer. Okay, so after this, I'll call myself a blockchain developer even at Christmas dinner. Yeah. Zombie army. So like there are this kind of stats. Earn a crypto collectible zombies and bonuses by completing coding lessons. By the way, I'm a big fan of zombies. I think I've watched all the possible zombie movies and also series. Nice. Clever Fair, we made this. Ah, there is a GitHub repository. What to go here? Loom Network. So there is a GitHub repository. Crypto Zombie lessons code. Nice. Okay. So. Nice. So I think we can start. I don't really remember. Okay. Nice. So the website looks nice, by the way. Free teaching platform. They say that that's free. I don't know how much that is free. Spit. Okay. Nice. So I think we can start. Let's start here. Start course. This one. Okay, so let's start from here. Nice. It looks very nice. Okay. In lesson 1, you are going to build a zombie factory to build an army of zombies. Our factory will maintain a database of all zombies in our army. Our factory will have a function for creating new zombies. Each zombie will have a random and unique appearance. Nice. Later lessons will add more functionality, like giving zombies the ability to attack humans or other zombies. Nice. Okay. How zombie DNA works. The zombie's appearance will be based on its zombie DNA. Zombie DNA is simple. It's a 16-digit integer, like this one. Just like real DNA, different parts of this number will map to different traits. The first 2 digits map to the zombie's head. The second 2. Okay, so we have up to 100 values for each zombie. If I do this. Oh, nice. I think I can stay here. Clothes, eye color, skin color. Nice. Nice. Okay. For example, put it to test. Play with the sidebar. Okay, so this was... I think everybody can do this. So this is just to test some stuff. The colors, okay. Crypto collectibles. Nice. I like the idea of this randomization. Let's go next. Okay, so this is nice. So we have some random stuff to define a zombie, which basically can be whatever. Starting with the absolute basics, Solidity's code is encapsulated in contracts. Hey Webster Codes, thank you for following. Nice, welcome. Solidity's code is encapsulated in contracts. A contract is the fundamental building block of Ethereum applications. All variables and functions belong to the contract, and this will be the starting point of all your projects. An empty contract named Hello World will look like this. Okay, so this is a contract. It's like a class. Version pragma. All Solidity core source code should start with a version pragma, a declaration of the version of the Solidity compiler this code should use. This is to prevent issues with future compiler version. The current version should be 0.8.11 if they haven't changed this in a couple of hours. This is the compiler version, potentially introducing changes, breaking changes that could break your code, breaking changes. For the scope of this tutorial, we will want to be able to compile our smart contract with any compiler version in the range of 0.5.0 to 0.6.0, here, exclusive. It looks like this, so pragma solidity, yes, and you're equal, putting it together. Here is a bare bones steering contract, the first thing you will write every time you start a new project. So when we start a new project, I think these are .sol files, but they are not talking about the extension of the file here. My goal would be to create a local development environment with Docker. So I don't want to copy paste because I think that to learn it will be better to write and make some but can you see, by the way, it will be bigger. It's better. Is it better? Yes, like this. Okay, so it's a pragma solidity, and then the version. So measure equal 0.5.0 minus okay until 0.6.0. so this is, I don't think it's super outdated, but maybe they need a new version. Contract hello world. I like a lot that on Solidity there is this kind of keywords like contracts instead of class, so it's super clear what we are doing. Put it to test. To start creating our zombie army, let's create a best contract called Zombie Factory. The contract, they want to call it like that. Okay, the contract. Okay, let's not try to don't copy paste. Zombie Factory. So factory. Okay. When you finish, click check answer below. So I hope that at least this I've done it correctly. Let's see. Okay, nice. I like the victory. Nice. Perfect. Next chapter. I don't know, should I say? Let's try to don't sign in. Let's see what happens. Chapter 3. State variables and integers. Great job! Wow! Now that we've got a shell for our contract, let's learn about how Solidity deals with variables. State variables are permanently stored in a contract storage. This means that they are written to the Ethereum blockchain. Think of them like writing to IDB. Example, contract example, this will be stored permanently in the blockchain. uint, for example, here we're starting to learn about the basic types, so the primitive types, for example, this uint. So this depends on the language, of course. Hey Sohail, there you go. You are late. I'm already at chapter 3 and I've already got a lot of congratulations just for writing a contract with an empty value. If life would be like that, it would be awesome. So, example. So this is like the example. In this example contract, we create a uint called my_int integer or integer and set it equal to 100. Okay, I can do it. Okay. Unsigned integers, uint. The uint data type is an unsigned integer means its value must be non-negative, so only positive, like the values that we learn in the when we are like 6-year-old. There's also an int data type for saying the integers, so we are already learning about some data types, which is not we need to check that, of course. In Solidity, uint is actually an alias for uint 256. Okay, I'm also going to try it now. You probably will be way faster than me because I'm also explaining, but if you want to do this with me, that would be awesome. Yeah, thank you, it's amazing. Basically, I was about to do this anyway, so since I'm shameless now, I do this in a live stream. This is the power of having a Twitch channel or YouTube channel. I want to learn something new, I can do this publicly. It's amazing. You can declare a unit with less bits. Okay, put it to test. How zombie DNA is going to be determined by declare a uint. Declare a uint named DNA digits and set it to equal to 16. So let's try to not copy paste. Let's try. So contract. It has a okay uint. So we are defining this. This is basically just to get used to that. So DNA digits, for example, here, here we learn also about the convention of writing variable names. So what I've written here, the equal to 100, set equal to 16. Okay, so 16 this way. And also there is a semicolon. So we are starting to learn about the basics of Solidity. I've already written some, like you can see here, the name of the file is contract.sol. I'm trying to create a Docker environment for Sol files. So when I'll be ready, I'll post about that, of course. Let's check the answer. Victory. I love that we got a lot of compliments. You have triumphed the Solidity cowards in front of your might. Lesson unlocked. Amazing. Okay, I'll try to skip this. So let's see how far can I go without giving any alien information. Nice. Chapter 4. But in Solidity is pretty straightforward. The following operations are the same as in most programming languages: addition, subtraction, multiplication, division. There is also the modulus, the remainder, which is the remainder of a division. For example, 13, for example, 10 module 2 is 0. Module 2 is 0 because it's the remainder of the division. Solidity also supports an exponential operator. Yes, with this symbol. Okay. Okay, so I can use this one or even this one. Nice. Okay, put it to test. To make sure our zombie's DNA is only 16 characters, let's make another uint equal to 10 elevated to 16. That way we can later use the modulus operator to shorten an integer to 16 digits. Create a uint. It's the same. Nice. It's the same file. I like this, that their lessons are connected to each other. Nice. Amazing. Okay. Let me sip a bit. So uint DNA modulus and set it to equal to 10 to power. I think I can do this. 10 of DNA digits. So I like this. And DNA digits. And there is also the I can also do this. Okay, so in this case, of course, this will stay 16. But let's say that we want to use a different number of characters. But the DNA digits, I don't have to change it in different ways. So nice. Let's check. Perfect. A lot of compliments. No. Sometimes you need a more complex data type. For this, Solidity provides structs. So this is a concept that is in different programming languages. So for example, struct person. I think we will create a struct called zombie. Yes. Struct person. So a struct is basically to create a more complicated data type that have multiple properties. Okay. For example, we have also a string with a lowercase initial letter. Okay, so now that you're just introducing the new type string, strings are used for arbitrary length UTF-8 data. Example, string greetings equal to hello world. Okay, in our app we are going to want to create some zombies, and zombies will have multiple properties, so this is a perfect use case for a struct. Okay, the only thing is that here is not explaining if I should create the struct. Hey there! Hey, thank you so much, Crows4K. Amazing, amazing. Thank you so much. This is a perfect Christmas gift. Thank you so much. Great, amazing. Okay, so I don't know if the struct should be in the contract itself or outside, but since I'm no, it says this start here, so this is a hint. Thank you, it really means a lot. The more support I'll have, the more live streams I'll do. Thank you. Okay, so let's create a struct called zombie, and here we will let's define two properties: name, a string, so string name, and then a uint, which is the DNA. Okay, let's check the answer. Victory. Okay, that was easy. Thank you. Let's go. I don't want. So until now it's super easy. It's more to get used to the grammar and the syntax of Solidity. Chapter 6, arrays. When you want a collection of something, you can use an array. There are two types of arrays in Solidity: fixed arrays and dynamic arrays. This starts to get interesting. Array with a fixed length of 2 elements. Okay, another fixed array can contain 5 strings. So this is the type of the elements of the array, and this is the number of the elements of the array. So fixed array, it means that we have a fixed length. Instead, we can also do a dynamic array with not a fixed size. Of course, it depends on what we want. You could also create an array of structs, which is very powerful, because I think we will create an array of zombies, but let's keep reading. Create an array of structs using the previous chapter's person struct, person, square brackets, people. So, for example, this is a dynamic array, so we can have as many people as we want. This depends. Remember that the state variables are stored permanently in the blockchain. What is this? A typo. So creating a dynamic array of structs like this can be useful for storing structured data in your contracts, kind of like a database. Okay. Public arrays. You can declare an array as public, so this is the access modifiers, and Solidity will automatically create a getter method for it. This is very useful, so we'll have a getter method automatically if you create a public array. I think it will create a public array of zombies. Let's see. Yeah, there we go. We're going to want to store an army of zombies in our app. We are never going to want to show all our zombies to other apps, so we will want it to be public. You are right. so let's do it. Let's call it like that: zombie, square brackets without a fixed number, and then the access modifier public, and then the name of the array, zombies. I'm liking this tutorial a lot, and I also thank you Crows4K for the subscription. Amazing. Perfect. Done. Easy. Let's go. I don't want. Okay, chapter 7, function declarations. A function declaration in Solidity looks like the following. Function it hamburger string memory is a keyword reserved keyword reserved word underscore name uint amount public. So it's not clear memory what is that, but I think this is explained very well. This is a function name eat hamburgers that takes two parameters, a string and a uint. So string and uint are the so these and these are the the modifiers. For now the body of the function is empty. Now that we are specifying the function visibility as public, so this is the function visibility of the function visibility. We're also providing instructions about where the underscore name variable should be stored in memory. So where do we want to store the variable? So okay, there we go, Del Void. Amazing. Thank you so much. Let's go. Let's go. How are you? Subscribed for 2 months. Amazing. Thank you so much. Thank you so much. Okay. Okay. What is? Yes. I asked at the beginning. I'm very good. This live stream will last for 6 hours. I've just getting started. I'm learning Solidity. And of course, I'm connected with Docker in some ways. Okay. So it's the only thing that's not clear to me is that okay, we have specified memory. So what's the default one? Is the default memory? Are they just explaining here? Hey, Mark is in the house. Amazing, amazing, my friend. Amazing, my friend. What's going on? Sumudu, thank you so much. Thank you so much, my friends. Okay. Okay. So I'm already at chapter 7. I started since chapter 1 until now. To be honest, it has been more to understand the syntax of Solidity. I'm not sweating yet. So, okay. So in memory, this is required for all reference types such as arrays, structs, mappings, and strings. What is reference type, you ask? Well, there are 2 ways in which you can pass an argument to a Solidity function. This is not just for Solidity, this is a general concept in programming. So you can pass by value and by reference. They say by value. Let's see if the definition it convinces me or not. By value means that the Solidity compiler creates a new copy of the parameter's value and passes it to your function. This allows your function to modify the value without worrying that the value of the initial parameter gets changed. So we pass just the value. Instead, by reference means that your function is called with a reference, okay, to the original variable. So the reference is of the variable. So if your function changes the value of the original variable also gets changed. Okay, let's read here. It's a convention to start a function parameter variable name with an underscore in order to differentiate them from global variables. Use that convention through the tutorial. Okay, you would call this function like so: eat hamburgers, Vitalik, the creator of the Ethereum, 100. Okay, so he'll hit 100 hamburger. Okay. Put it to test. In our app, we are going to need to be able to create some zombies. So let's create a function for that. So create a pub. So here I like this because we are learning the syntax of Solidity, because probably we have used the different languages that define a function for different languages. Now we are defining this especially and dedicated to Solidity. So let's create a public function named create zombie. So for example, there are no shortcuts. Also the keyword is function. I like this, to be honest. It doesn't have to be fun for some I mean fun, but I don't know. Create a public function named create zombie. So the name, if you want to follow along, you can. Now, so this is the name of the function. Maybe there is no space, but this function does nothing. Should take 2 parameters, underscore name, a string, and a DNA uint. Don't forget to pass the first argument by value by using memory word. Okay, super easy. They are saying literally everything. So string, and now let's see if I can. For example, memory has to be said before. Okay, right. Memory. Okay. I was expecting this to be in a different color, but it's okay. And then uint, how is it called? DNA. Yes, I'm perfect. It's right here. Amazing. Should do something together one day. Don't forget to pass the first argument by value by using the main memory. So the first argument by value by using the memory. Okay, so I think this should also be memory. Let's see. That's Twitter. Name and DNA. No, only the first argument. Let's try. No, what I've done something wrong. The first argument, my memory. I'm doing something dumb probably. String memory underscore name and then okay. I forgot the public. Okay. For example, this is not something that you have in all the languages. Oh, sorry, baby. Can you read? Okay, let's try. Okay. So I forgot. I made my first little mistake, but I think I'll do way worse later. Okay, I can't remove it. Okay. Okay, chapter 8, working with structs and arrays. But this is getting interesting and it's super simple. Creating new structs, we are also close to 10 words. Creating new structs. Remember our person struct in the previous example? Probably not, but here is an example. Now we're going to learn how to create new persons. There are some little typos, and add them to our people array. Person Satoshi, they're using names which are famous in the crypto world. Dot push, this looks familiar. People dot push Satoshi. Okay, if you are already familiar, for example, with JavaScript and Python, it's simple. Mark, my friend, I will literally do this just for you. But if you are here, it's also a great thing. Thank you so much. Okay, note that array.push adds something to the end of the array, so the elements are in the order we added them. See the following example. Okay, uint. This is a dynamic array. Remember, dynamic array, so it is not a fixed number. Don't confuse this number with the type of the array. This can be an error. Here we can have as many uint we want, but we are pushing numbers here. So I can also do here numbers.push 20, I don't know. Okay, I like this. I like this a lot. That there is this start here, and then here you write stuff. It's very cool. It's very cool. Because sometimes you say like do this, but I don't know if you should do this inside or outside. So okay, it creates, okay, fill in the function body, so it creates a new zombie and adds it to the zombies array. The name and DNA for the new zombie should come from the function arguments. Okay, so we have the structs. Okay, so zombies dot push. I need to do the zombie. It creates a new zombie. First we have to create the zombie and then we push it. Okay, so create the zombie and push it to the array. Okay, this makes sense. Feel free to also say what you think about this. Okay, so zombie, but should we create because this is create zombie. Okay, so let's create it was a famous zombie, Carl. Now let's create okay, Carl, like that. Equal to zombie. But here we have let me see, here they are starting to do something here. For example, the name of the zombie, it will be Carl, because we need to follow here. Here we have string and int. Here they have first the number and then the name. Okay, nice. I like this a little. It's not started to become a little bit harder. And the DNA, but the DNA, I was expecting maybe something like that. Let's start with something hard-coded. So let's try with 100 or 10. But probably this in the future will be 6 digits. Okay, so we have this, and now we can just push card. We can also do this in one line. Okay. Okay, so let's do like that. They want to do this in one line. Okay. To be honest, I'm not super fan of this, but okay. Zombies. Push. Zombie. Okay. Let's see. It should work. No, I've done something wrong. String name, uint, DNA. What's wrong here? Zombies.push. But I need to define. Okay, let's see. So it says I need to define the arrays also inside here. Let's see. Okay, this is okay. This looks okay. I don't want don't check. Instead of Carl, it should be underscore name. Right, because we are passing. Sure. You're using the variables. I was doing an example, and here the DNA underscore, of course. Thank you, Sohail. Let's check. No. From the function argument, zombie underscore name uint underscore DNA semicolon. Right. Because in JavaScript is optional. I think it here is not. There we go. Thank you, Sohail. You're amazing. Okay, chapter 9. Private public functions. In Solidity, functions are public by default. This means anyone or any other contract can call your contract's function and execute its code. I made a thread today about this. Obviously, this isn't always desirable, and can make your contract vulnerable to attacks. Thus, it's a good practice to mark your functions as private by default, and then only make public the functions you want to expose to the world. Let's look at how to declare a private function. So, to declare a private function is exactly the same, but there is this private keyword. Okay. This means only other functions within our contract will be able to call this function or the numbers array. If you are familiar with object-oriented programming languages, this is basically a contract is similar to a class. As you can see, we usually use the keyword private after the function name, before the body of the function. And as with functions parameters, it's convention to start private function's name with an underscore. So if we have a private function, the name of the function should start with an underscore. And I think that conventions are important. Put it to test. Our contract create zombie function is currently public by default. This means anyone could call it and create a new zombie in our contract. Let's make it private. Modifier create zombies, its private function. Don't forget the naming convention. They should not have added the last one. I would probably have forgotten this. If I add hint? No. There we go. Okay, let's go. Chapter 10. More on functions. In this chapter we are going to learn about function return values and function modifiers. Return values. To return a value from a function, the declaration looks like this. The string greeting equal to what's up dog. Okay. Function say hello public returns string memory. Return greeting. So the syntax is a bit complicated, but I like that we are defining the return value of the function in the beginning, before the body. So the function declaration contains the type of the return value. The function declaration contains, I'll say it can contain, because we have done already this without, or maybe it has to. I don't know if that's mandatory or not. Function modifiers. Okay, the above function doesn't actually change state in Solidity. It doesn't change any values or write anything. So in this case we could declare it as a view function, meaning it's only viewing the data but not modifying it. Okay. Because it doesn't change the value. Okay, so just return something. Okay, easy. Solidity also contains pure functions, which means you are not even accessing any data in the app. Considering the following. Okay. Perfect, so we are not changing any value. This function doesn't even read from the state of the app. Its return value depends only its function parameters. So in this case, we will declare the function as pure. It may be hard to remember when to mark functions as pure view. Luckily, the Solidity compiler is good about issuing warnings to let you know when you should use one of these modifiers. Nice. Put it to test. We are going to want a helper function that generates a random DNA number from a string. Nice. Create a private function called underscore generate random DNA. It will take one parameter named underscore str, a string, and returns a int. Don't forget to set the data location of the underscore str parameter to memory. This function will view some of our contrast variables, but not modify them, so mark it as view. The function body should be empty at this point. We'll fill it later. Nice. So everything looks, at least the explanation looks great. So function, it's called generate random DNA. So this means that the function, it will be private. Then this will be the parameters, and then I like to see it here already before I forget that. So we want a string memory underscore str and returns a uint. So private view. I think it's private view. Private view returns. Private view returns. Private view returns uint. Just the type, of course. Uint. And the body empty. What is this? Like this. Let's see if it makes sense. String returns string memory. Yo, I finish. There we go. 0612. The function will view some of our contrast variable, but it should be empty now. Okay, I don't know if I have to put also memory. No, let's try like that. There we go. We made it. Next chapter. Chapter 11. Keccak256 and Typecasting. We want our generate random DNA function to return a semi-random. Of course, we can talk hours about UInt. You are doing game dev. No, this is not game dev. I'm learning Solidity. How can we accomplish this? Ethereum has the hash function Keccak256 built in, which is a version of SHA-3. A hash function basically maps an input to a random, to 256-bit hexadecimal number. A slight change in the input will cause a large change in the hash. It's useful for many purposes in Ethereum, but for right now we are just going to use it for random number generation. Also important, Keccak256 I think I've added this just yeah. no, it's software development. Also important, Keccak256 expects a single parameter of type bytes. This means that we have to pack any parameter before calling Keccak256. I don't have pronouncing that well. So start here. As you can see, the return value are totally different despite only a 1 character change in the input. Now, secure random number generation in blockchain is a very difficult problem. Our method here is insecure, but since security isn't top priority for our zombie DNA, it will be good enough for our purposes. Yes, okay. Typecasting. Sometimes you need to convert between data types. Take the following example. You have a uint 8, a equal 5, uint b equal 6. Throws an error because a multiplied b returns a uint, not uint 8. We have to typecast b as a uint 8 to make it work. This is basically the typecast. Okay, nice. In the above returns a uint, but we are trying to store it as uint 8. Cause a potential problem. By casting it as a uint 8, it works on the compiler won't throw an error. Nice. Let's fill in the body of our generated random DNA function. Here's what it should do. 1. The first line. What is this? Sorry, it's a bit bugged. Okay. What is this? Okay. Nice. The first line of code should take the Keccak256 hash of ab dot encode packed string to generate a pseudo-random hexadecimal. Typecast it as a uint and finally store the result in a uint called rand. So, okay, so we have to work on this one. So the first line of code should take oh no, let's say don't copy, so it's easy for me to remember in the future. Keccak256 b dot encode packed of this underscore string. Okay. To generate a random pseudo-random as a uint. Okay. I shall store this somewhere. Okay, but I think I should store this in somewhere. Okay. To generate a pseudo-random hexadecimal. Typecast it as a uint. Okay, so typecast this as a uint. And finally store the result in a uint called rand. Uint rand equal. Usually I don't add semicolons because in my IDE I just added. I like the semicolons in JavaScript, but I don't add them by hand. I let my IDE do that. We want our DNA to only be 16 digits long. Remember our DNA modules? So the second line of code should return the above value modules. Okay. I don't have put in here. So, second line of code should return the above value. Return rand module DNA modules. Let's see. No, I made an error. Let's see what can be the error. Maybe like this, because I don't see the errors. Ah, no, here. Ah, a typo. But the error is, why is it like that? It's a bit bugged here. Let's try. No, there is an error. And why I can't spell encode pact? Okay, okay, nice. Now I remember the name of this function forever. Nice. Let's go. Chapter 12. Putting it together. We're close to being done with our random zombie generator. Let's create a public function that ties everything together. We are going to create a public function that takes an input, the zombie's DNA, the zombie's name, and uses the name to create a zombie with random DNA. Put it to test. Create a public function named createRandomZombie. And as you can see here, we don't have the underscore at the beginning. It's a bit bugged because okay, can you see like that? Or you want it bigger? Let's see. So function create random. I put this a bit to put this microphone in some other ways because it's a bit. Create random zombie. Create random zombie. So I like to write this here before I forget. Public. So the parameters are to take one parameter named underscore name, a string with the data location set to memory. So string memory underscore name. So we create a random zombie with a name. It will take just one name. Oh, okay, string. Okay, declare the function public just as you declare the previous functions private. Okay, the first line of the function. And what should we return? We're not saying what we will return. Okay, let's try. We're not taking explicitly what is the return type. Public zombie. The first line of the function should run the underscore generate random DNA. So if I do this, generate random DNA function on underscore name. On, using this as a parameter, and store it as a uint named random DNA. So uint random DNA. Okay, so I do this. The second line should be run the underscore create zombie. Underscore create zombie. So this and pass it underscore name, which is defined here, and run the DNA. Makes sense. The solution should be a check answer. Perfect. Nice. Okay. I like it. What's this? Chapter 13 Events. Our contract is almost finished. Let's add an event. Events are a way for your contract to communicate that something happened on the blockchain to your app front end, which can be listen for certain events and take action when they happen. I'm a great fan of events. when I've been coding for Unity 3D, I was using events all the time. It was very, very useful. Example, declare the event. So event, it's a keyword here. Can you see? I hope so. Integrals added. So this is an event. It's a uint x, uint y, uint result. Function add, uint underscore x underscore y. Public returns uint result equal to underscore x. Okay, it makes sense. So we have this event, and then maybe they could have explained what an emit is. Are they saying this or not? Okay, emit is to basically say that the event basically happened. I like it a lot. I like this logic, because for example in game development this is super useful. Like, I don't know, the player has been damaged, or the player has done something, has killed something, and you get an increase counter for example. Okay. So where should okay, here. Declare our event here and fire it here. Okay. Your app frontend could then listen for the event. A JavaScript implementation would look something like your contra.integrals added, function error result, something will result. Okay. Put it to the test. We want an event to let our frontend know every time a new zombie was created, so the app can display it. Declare an event called new zombie. I love this. This event. I think tomorrow, even if it's Christmas, I'll create a tip about the events in Solidity. So the event is new zombie. It should pass a zombie ID, uint, a name, and a DNA. So we have zombie ID, name, and DNA. Okay, so the type. So the type is. You see here at the top. What, a bit bigger? Okay, that's right. Because it's a bit bugged. Can you see here? It's a bit. Maybe like this. Come on. So uint. Uint is the zombie ID. Hey, finish. You don't want me to put a Christmas hat, right? I just been to the barber. Just had a haircut. Zombie ID, a name which is a string name, and a uint called DNA. Like this. Okay, so we have the event. Okay, nice. I love it. I love this, really. And then modify the underscore create zombie to fire. I like fire. To emit. To fire the new event. To fire the new zombie event after adding the new zombie to our zombies array. Okay, you're going to need the zombies ID dot array dot push. Returns a uint of the new length of the array, and since the first item in the array is indexed 0, array.push -1 will be in the index of the zombie we just added. Store result of zombies.push in a uint code ID, so you can use this in the new zombie event in the next line. Okay, this is not super clear, but let's do it. Emit. They're not talking about this, but let's see. Okay, we need this in the function, and then we fire an event. Zombie added, something like that. Zombie added. So this should be the event. So we push, and then with the event you can emit can you please explain the last point 3 on how to get that array ID? I'm reading this for the first time with you, but let's read it again. Yes, you're right. You're going to need the zombies id dot array dot push. No, because it's because this is not the function. You're going to need the zombies id dot array dot push returns a uint of the new length of the array, and since the first element in the array is index 0, array dot push minus 1 will be the index of the zombie we just added. Dot store the result of zombies dot push minus 1 in a uint called id. So this is like something like that. I think it's like uint id equal to zombies result of zombies dot push. The result of zombies dot push in an event called id. Okay, so it is Ctrl X. This we need to store this here. Can you read? Only want it bigger. Uint id. So we need uint id equal to zombies dot push. So we need this id, but I think that we need to minus 1. Okay. Store the result of zombies push minus 1. So you can use this in the new zombie event. The new zombie event. The event is called new zombie. So you can emit. We have to emit the name of the event. Emit the event. Okay. Event emit new zombie. Okay, so let's go here. Okay, so when we emit an event, we need to pass the parameters of the event. So the event has a zombie ID, so this will be ID, then a string name, which is the underscore name, I think, and then the DNA, which is underscore DNA. Let's see. No, there is a small error. Okay, let's see what's the problem. Uint id zombies.push zombie is -1. They don't say what's the problem. Maybe it's this. It was just a semicolon. The only thing I don't like is that once you are done, you can't go back on your code and check that. Okay. Done. Let's make a pause. Cool. Chapter 14, Web3.js. Our Solidity contract is complete. Now we need to write a JavaScript. JavaScript is not written like that. It has a capital J and a capital S. Come on. That interacts with the contract. Ethereum has now is written with a capital J and not a capital S. Are you kidding me? Called Web3.js. In another lesson, we will go over in depth on how to deploy a contract and set up Web3.js. But for now, let's just look at some sample code for how Web3.js would interact with our deployed contract. Don't worry if this doesn't all make sense yet. Okay, so we will not worry. Here's how we will access our contract. Why are you laughing, Sahil? Thank you for staying here, by the way. Okay, var ABI generated by the compiler, zombie factory contract. Okay, web3.eth.contract, var contract address. Let's try to get familiar with these concepts. ABI.eth.contract, var contract address. Maybe this is the. Okay. This is bad because I can't scroll. Oh no, I can. Yeah. Okay. Yeah. Let's go here. Sorry. So zombie factory equals zombie factory contract.at contract address. Yeah, because they hate JavaScript. Okay, some sort of event listener to take the text input. Okay, so this is an event listener in JavaScript. Click function. Nice, I like this. Okay, so we can add this to some JavaScript code. Okay. Listen for the new zombie event and update the UI. But event was equal to zombie factory.newZombie function error result if error return okay. Why there are not semicolons? Because this is JavaScript. Okay, but without semicolons. Okay, so this is basically the web3.js is the JavaScript library. So it is an Ethereum JavaScript library. Okay, makes sense. Okay, take the zombie DNA and update our image. Okay. That's zombie details. I don't want to read everything, but basically these are the details of a zombie: head, eye, shirt. They should be 8. 1, 2, 3, 4, 5, 6, 7, 8. We have two digits for each value, which is a lot. What our JavaScript? JavaScript. Why like this? But they want to be called Solidity programming language, otherwise they get mad at you. I'll put a link later we'll check it. We have to call it like that. Ah, they're using Vue.js. Mark, where are you? He left. Use some browser-based JavaScript magic. Okay. To zap out the images and apply CSS filters. You will get all the code for this in a later lesson. Give it now. Give it a try. Go ahead, type in your name to the box on the right and see what kind of zombie you get. So this is perfect because now if you are in the chat, just write your name and we will generate some zombies for you. For example, I can take this one. Okay, this was not a test. Lesson complete. Congratulations, you have completed lesson 1 of Cryptozombies. You're officially one step closer to building your own games on Ethereum. Why are we not doing this? Show off your first zombie to your friends. Here's a permalink to your zombie. Make sure your progress is saved below before you proceed to lesson 2. You can find the source code of the lessons of this guy. Sign in and save your progress.